Now that you have an idea where you stand on the political spectrum, let's do the hot and cold water molecule experiment to get an understanding of how your brain works. Note that your brain is an extraordinarily complex organ with billions of nerve cells, neurons, all interconnected and firing away to generate your consciousness and sense of self. Note also that at conception you are just one cell, one single human cell in the womb. And from there, that one cell divides continually with the guidance of your DNA to become you, all 37 trillion cells of you. Now, keep that in mind as we go to the hot and cold water experiment. First thing you need to do, get 3 containers. First one here will contain the cold water. Pour some tap water in, put a whole bunch of ice in the container. The ice will bring the temperature down to 32 degrees. Let me check. Yep, 32 degrees. Freezing point of water. As long as there's ice in there, it will be 32 degrees. Second container, pour regular tap water, cold tap water, into the container. Then bring the temperature of that water to 70 degrees. Our tap water here was about 75 degrees. We threw a couple of ice cubes in there, brought it down to 70 degrees. Here's the hot water. This hot water is 108 degrees. All we did was pour hot water out of the tap. That water came out at about 118 degrees. We poured some out, added some regular tap water, cold tap water, and brought the temperature to 108 degrees. Note that you don't want to go higher than 108 degrees because your skin is sensitive. You don't want to hurt yourself. So, here's the experiment. Take your left hand, put it inside the cold water. Leave it there for 10 seconds. Note, it's not very comfortable. There may be a little bit of discomfort and pain in there. After 10 seconds, take it out, put it inside the warm water. Note how it feels. Then, take your right hand, put it inside the hot water. Leave it there for 10 seconds. That's not very comforting either. 10 seconds. Then, put your hand in the warm water. How does it feel? All right. Now, take your left hand, put it in the warm water. Note how it feels. Take your right hand, put it in the warm water. Note how it feels. It feels significantly colder. This water is significantly colder than with my left hand. But wait a minute, it's the same water. How could it feel colder with one hand and warmer with the other? Something's not right here. How can that happen? Well, the answer lies in your brain and how your neurons interpret input. If your brain is accustomed to cold ice water, then the difference in warm compared to cold neurologically registers as a lot warmer, a larger difference. If your brain is accustomed to hot water, then the difference in warm compared to hot registers as a lot cooler, a larger difference. And when you compare that feeling of temperature in your left hand to your right hand, you can see that the brain has overcompensated. It's overcompensated the differences in temperature, and your hands feel different temperatures at the same time. Note, it's all relative. That's how your brain and neurons operate. Another example. Have you ever seen the moon on the horizon when it first comes up in the evening? Doesn't it look huge? I've done it many times. I still can't figure it out. It looks huge. Wait 3 hours, go look at it high in the sky. It looks like the dinky little moon that you're accustomed to. How can it possibly be that the same moon looks huge in one context and small in another? It's all relative. It's how your brain interprets your surroundings. The thought is that with the horizon acts as a data point from which your brain compares the size of the moon. For whatever reason, makes it look bigger. Once it gets up high in the sky, with no data points around it, it shrinks in your head. As Einstein said, it's all relative. That's how your brain and your neurons operate.